so that the people who are standing in the hallway and waiting for this to start happening would hear us and join us. 10 o'clock sharp, it means we're starting the program. It's good to have on the stage people who affect not only online or mobile, but who have the effect to the offline, to the people. And it's also good to know that there's a high level of seriousness in this job. You ready, my friend? A real person that works in a real bank on the stage for you right now, Andrei Tuchin. Get your questions ready.
Yeah, welcome everyone. And today we'd like to discuss how to build huge risk systems in big banks and in common how it's done. So let's start. There is a small disclaimer. So if you're talking about that presentation, it's mostly my own view on all our buildings, on all our risk systems, and all presentation provided only for information purpose. And if you'd like to implement anything in your future work, in your future projects, please ask big engineers. So. If you're talking about risk systems, it's mostly related to calculate a huge data set with different market data in some reasonable time. So to provide information on the final risk for business people and to control that risk inside of your company. If you're talking about, just let me introduce some understanding of business. So there is I believe everyone, if we are talking about trading, for example, FX trading or equity credit trading, everyone knows about big movies. So for example, it looks like a simple job, just buy low, sell high, and everyone happy. But finally, in fact, huge financial services do not work in that way, mostly because it's very riskful. But big companies, big banks would like to make money without any risk. Because if there is a risk, there is a risk also to be closed tomorrow. And no one would like to be fired tomorrow, right? And for that purpose, all big banks, all financial institutes would like to develop and sustain risk in a right way. So finally, if we are talking about a business, there is no any speculation, because speculation is a risk, and no one would like to take that risk. And mostly, huge financial service providers, they make money from service. They not make speculation, but they sell service to another companies. For example, Apple, or for example, any car maker, meals, for example, bread maker, or anyone. So because these companies and other companies make profit from product, from production, but they're not so good in financial and in finance. And finally, at the end of the year, every year, they should submit a tax, and they should just provide actually clear about their business. But, for example, if you are talking about Forex or FX rate, it's going low and high all time. And they're not sure about future. So they approach a big, huge banks and ask for help. And the question is simple. Like, please, I'd like to fix some rate, some change in financial world in future. And the huge bank, for example, just, yeah, sure, but you should to pay for that. And we fully take your risk for some reward. And finally, we are ready to manage that risk in proper way. So business is simple. I take a risk for money. And it's my part of job to care about that risk and provide service for companies that are not so much experienced, not have products, not have applications for management. So, for example, yes, a simple example, cross-border payment. So, for example, if you send USD to GBP, that rate may be fixed in contract with bank, and that rate finally will be executed. So, talking about, let's also make some introduction about the terms in that presentation. A transaction and trade, it's the same. So some people use transaction, some people use trade terms, so it's the same in current presentation. Also, if we are talking about different contracts, it's also about transaction and trade. So talking about numbers, for example, in our current implementation, it's all numbers in approximately in some, not exactly these numbers, so because, and all this it's approximation. Talking about, for example, FX business, right now we have around from million to 10 million transactions per day. So it's not so much, for example, comparing to huge companies like, for example, Google or Meta. But it's actually a huge amount of information because, for example, one transaction has 1,000 fields and information about, for example, expiration rate, source, which trade made execution and will make execution, and all that information. So million to 10 millions, it sounds very low, but in fact, it's a huge amount of data. Also, sometimes there is very complicated composite transactions, and it's around 10K per day. And also, as I mentioned, there is a huge number of different metrics. And per single transaction, per single trade, we have around 50 risk metrics. Also, if you're talking about risk, for example, if you're working in financial department or you're developer of financial application, you understand what means risk. It's maybe different data, Vega, Theta, and another. But for today, for that presentation, think about risk as a simple computation. So it's just some metric. You take some input, for example, 2 numbers, and finally it's some result. So risk, it's just some metrics that we'd like to calculate and finally present for someone. Also, it's very important to update our metric in daily basis. So, for example, because there is no reason to have a risk if it's not updated, right? Because rate all time changes, or for example, market state all time changes. But if you'd like to keep it in updated way, you should also recalculate that metric with some time period. So we updated it approximately 10,000 times per day. Also, we use different spot shocks, day shocks, and another shocks per single transaction. And finally, after all these multiplications, we have around 10 trillion calculations per single transaction per day. So it's a huge number. But and this number should be preceded. And the main question, how to do it, right? Yes. So let's start with some very short history. So why it was done? So it was initially paper. It's a mistake, human errors, and all that stuff. So it was actually not efficient. But talking about this system, so it was developed 40 years ago. So no computer, right? After that, next step, it's small automated computation. It's approximately from something like 1990 to 2010, yes, approximately. It's Python and Excel scripts. But there is a poor performance, no development cycle, no roadmap, mostly developed by some traders for their desks, so there is no any experience in application development. And finally, we have approximately the current state. It's huge monolith applications. For example, it's like a big black box. Input data, transactions, output, just a number. And there is literally no scalability because, as I describe later, all these parts should be replaceable. I believe you know, yes. And very expensive development because, for example, if you have a team of 100 guys stacked on the same UAT environment, on the same application, it's you just can't test your application, right? So It's a very expensive development, so your cycle is huge. And finally, modern risk systems. It's mostly distributed systems. And to split all that application into multiple models with very important clear API, different teams, and fast development. Because, for example, every team, for example, in our branch, we have a team approximately 10 people. So 10 people stacked for one application, and they proceed every testing, all testing in their own environment, so there is no any issue. So let's split into different systems. First of all, let's talk about architecture. So if you're talking about a calculation, transaction, and all the stuff, we definitely would like to do it very fast, right? But if you're talking about risk calculation, it's not fast as like milliseconds. But if you're talking about timeline, it's approximately up to 10 minutes. So for example, if there is some change in market data, or for example, new transaction, new trade, business people expect to see a result in 10 minutes. So it's not very fast, but it's actually a reasonable number. So we have a trade market cache. Let me just. So architecture is very simple. We have a trade market cache. It's left top side. It's mostly done for providing transactions and market data. Just a simple orchestrator to run and control timeline on execution and calculate a service. It's a service with a server grid, with a library on board, and calculation done in that place. And very important place, risk storage and publisher. User and UI, it's with backend, yes, in the top right. So let's consider these parts step by step in terms of numbers and issues we resolved in development process. So talking about trade market cache, so all transactions, all market data, especially it's very stored in Oracle SQL. So it's very strictly, and we know about model. But main issue, for example, if you'd like to update another systems with new trades, new transactions, it's slow because, for example, we should download, we should update, and maybe it's like updated, maybe there is some performance degradation or any other issue. But finally, we'd like to receive our trades, our information. So for that purpose, there is around Oracle database, there is also another system to keep all cache, all trades, and all transactions inside. So another application can fetch this information on call. So, but there is a little bit issues. So talking about numbers, we split our cache into main models, historical and current state, the last version. Because mostly not for all applications required actually like a long historical information about all versions. And mostly all applications would like to use only the last version. So I want to know current state. I want to know the last state. And it's main reason why there is only 20% of our power dedicated for historical cache and 80% dedicated for the current state. So just think about a cache, and for example, if you'd like to implement it in your workspace, it's think about a business case, not think about that I want to keep everything. So just keep something that you actually required for 80% of your execution. So issues, huge memory consumption. For example, in our case, it's almost a huge monolith solution because how to split cache if you have a dependency between different transactions? How to split cache based on some different types? How to split cache based on some different risk type? It's in many cases we found that it's not possible from business point of view. And finally, we have a huge instance with around 100 gigabytes per single instance. And it's a huge problem. It's the main reason why we implemented this Java native memory control system. And also there is another issue. So how to load all this 100 gigabyte in our cache in case of restarting? Because, for example, if you'd like to deliver it to the cloud, it's, your instance may be just shut down and restarted. And, for example, if your restarting takes half hour, there is no possibility to do it. Because, for example, you have 10 instances in the cloud, and all 10 instances restarted. And finally, for half hour, there is no service, right? So, yes. And another issue we found, it's thousands of different settings. So, if you're talking about business and different data types, different transactions and dependency, everything should be controlled. And it's also one of the points why this system is not in the cloud, because we'd like to have settings, and we'd like to run these settings in live mode. So, for example, if someone from trading side or from sales side comes to us and asks, guys, we'd like to, for example, run beta cache, not for this risk type, but for another, because today is a special day. Yes, we can do it. And it's also a huge issue. Talking about the team, for example, right now it's around 5 people just dedicated for that system. And the next one, I believe the most simplest, but also it's not simple in implementation, Orchestrator. It's systems that, let me just show. It's a system that controls full calculation in terms of scheduling and the timeline. So, for example, if you'd like to calculate risk, it's very simple. But if you have to calculate thousands and millions and trillions metrics, there is some bottlenecks in scheduling. Because, for example, if you'd like to calculate it like now, everything now, it's not possible because you have a limited hardware, you have limited resources. And in that case, should be some way distributed all these transactions, all these calculations in timeline. So it's also implemented with Java, some Kubernetes zookeeper and the load balancing. And I'd like to say that comparing to the cache systems, it's very good scalable, and it's mostly be delivered to the cloud. So, for example, in our main state, there are issues. Concurrency. First of all, concurrency, because if you'd like, for example, to send your transaction for calculation, you should fetch information about transaction, you should fetch market data, but also you should fetch information about your current loading on the grid, what current state of that transaction from the past run, and also, for example, which risk you'd like to calculate. So everything should be fetched from different systems. And finally, it's everything in one point. And from development point of view, it's concurrency is a huge issue because the developers should understand it. And from management point of view, all these people almost not possible to replace. And there is no way to hire anyone from the side. So it's not so much about architecture, but it's mostly about management team and how to calculate everything in one place. So how to run this system finally for business. Also, it's the same issue like for the cache, because that system uses the same data. It's memory consumption. And from this point, it's also there is some days, business days, when everything, so for example, as I mentioned, should be calculated like immediately. I want to calculate it now. For example, central bank change rate for banks. And in that case, everyone like waiting that minute, literally waiting that time, and start for calculation. And traders, business sales, they just push buttons, and finally, orchestrator should resolve that issue because everything can't be calculated immediately. But and following settings, following priority for different business branches, this should be calculated, but not immediately. And for example, talking about orchestrator, there is another trade-off in our system. For example, you can't just load this hardware with everything, with just put resources and calculate everything very fast. But, for example, if 90% of your resource is not used in timeline, business management directors, they ask you, sorry guys, but you waste money because 90% of time your system is not used. It's used for some peaks, but finally it's not in usage. And in that case, please move it to the cloud and make some amendments. So for example, to request or drop resources. So it's also a huge issue and a huge point. And also second solution of that question, to not to calculate everything like immediately on request. Calculate before that requested. So for example, it's simple idea, but in many teams, this idea is not like so obvious because people would like, if they're thinking about calculation, they would like to calculate it now. But in fact, if you talk with business, if you talk with traders, with stock project holders, it's not required. They are ready to wait, and it's the main point of building our system. So not all calculation done immediately. It's done, it's postponed, and there is delay, and it's just not important for people. They are ready to wait. So another important point, it's risk storage. It sounds very simple. Everyone like, yeah, I know risk storage. I know any storage. I know Oracle database. I know Mongo database. I know another. So it's simple. You just take your data, put in that place, and after some time you just use it, right? But in our system, initially was used Oracle database because it was a small application. It was everyone knew about Oracle database, and everyone was prepared to use it. But finally, we found it's very not efficient. Why? Because if you're talking about risk types, for example, calculation different risk fields in database, all time changes. So, for example, if trader would like to calculate one more another metric, it's calculated and it should be stored. And honestly say, for example, for now, a development cycle of any new field to implement any information in production and, for example, implement another calculation metric, it's approximately just one cycle. So there is a request from business, I'd like to implement one, and there is just one setting. We add that into settings, and it's in database. So there is no requirements to support schema, there is no requirements to support everything. And for that purpose, it's mostly why we used Mongo database for storing and all our calculations. Another point for Mongo database, we do not overwrite any information in our storage. So we just calculate it, put it, and use it. So there is no overwriting. It's a very important point because, for example, if you'd like to overwrite and there is a question about transactions. There is a question how to control consistency. There is a question how to control consistency between different instances. So it's huge, many questions. But for us, we just put it. There is no overwriting. There is no strong schema and no changes. So yes. So it's a main question why we made preference to Mongo database. Also, yes, publisher. Yes, publisher. It's everything that provide information for downstreams. For example, recently, my friend from a small company, from financial small company, approached me and asked, for example, we'd like to build initial risk application system. So we fetch market data, we fetch data from different centralized exchanges, and we calculate it and put it to some place for storage. Main point, he considered to calculate and put raw metrics. So everything that calculated, he persisted to database and when users would like to see that data, he took the data from database, aggregated in some different way, and provided for users. And my first question was like, why do you aggregate on request? Why not aggregate it before putting it to database? Because do you actually need all this raw data or not? So after some discussion, we found that he has no idea about business. So how to say, not in bad way. I believe he has no idea because all these questions was not asked. And mostly, if you are talking about after 10 years, we got main idea. Not keep some, if you not need raw data, not keep it. Because it's waste of resources. There is just simply no reason to keep the data. If you'd like to keep it in some another place. For example, in time series database, for example, ClickHouse and KDB. But if you'd like to actually provide reports for users, keep only aggregated state. For example, if you have 10 transactions and your user would like to see only a position for that portfolio for your 10 transactions, keep only one number. There is no reason to keep everything, right? And because for our systems, we found there is no one business requirements when we actually need to keep all data. Because no one would like to see 10 numbers. Only finally one number is important, like position for some portfolio, no anything else. And yes, and finally calculator service. So if you're talking about computation and metrics risk, it's important how we did calculation. So for our environment, we run 5K cores approximately. So it's our internal cloud. We have no any external clouds. We not have Amazon or Google or Microsoft clouds. So everything inside, mostly because it's pretty sensitive information for financial providers. And also we use C++ Python library, especially for calculation. So it's like a small library. We deploy it to each core, and it's like a black box, some input, some output. So it's very simple in terms for me, because I'm running all this risk environment, but literally I do not care about how that metric calculated. So I want just a result. If, for example, someone tell me that number is wrong, I go to developers of that library and I provide them information, I provide questions, and I ask why this metric is wrong in conformity with opinion of business, not my opinion, business. And also we run Redis for in-memory cache. So let me explain why cache also used in calculation. Different time points for the same transaction. Different market data. But for calculating risk, some calculations from the past may be reused. So yeah, reuse it. And for our server grids, we run Redis with reusage. It's simple mapping. There is a transaction ID, version, and pre-calculations that may be reused. Also, if we are talking about that one library, any one additional for loop iteration for risk calculation, it increases resource consumption up to 30%. So it's very good optimized. And talking about, yes, timeline. So if I'm talking about risk systems, it's everything about timeline. So portfolio calculation may take from 1 minute to 4 hours. You're like 4 hours. It's not life risk, right? Yes, but for example, if you take these 4 hours in the night period, it's life risk, because there is in night period for some exchange, that exchange is closed, so there is no update. So you calculated the last time step, and there is no update. It's the same risk for these 4 hours. So why it's not live? It's live, but with some tricky approach. So it's main point. So for example, if we have a long running calculation, we just postpone it or make it in some night period. Or for example, business, we actually like, for example, if business knows about there is 4 hours for calculation, but and there is no way to improve it for now, business knows about when that risk calculated and what exactly it means. And finally, yes, as I mentioned before, for example, for cache and orchestrator, there is a huge amount of data. So everything should be finally delivered for the users in some application. And it's main question. How to keep a state for user? Should we at a state on UI side or backend side? Because, for example, user opens application and current state risk now. But, for example, next trading activity, next change in market data, and it's not live. But user can't just follow all the switching numbers all time. Users, traders, they're not looking for the display all time. They're looking now in 10 minutes, in 10 minutes, in 10 minutes, in 10 minutes. They wouldn't like see all these switching numbers. So it's finally there is a state. And that state also should be managed because state supposes that you have all data in memory. And there is a main question, how to organize the state. So for example, for some of our applications, state is in a UI path. So there is configuration, there is timelines, there is which risk type, which configuration used. But also for some our applications state in backend side. And we communicate with UI, with protobuf, and request from UI and back. Latency, for example, from business, for trading activity, for new trade, it's up to the half second. What means half second? Is it only for backend UI? No, it's for the full cycle, from the cache, when a new transaction appears in database, to the final result in UI side. And you're like, sorry, but you say it from 1 minute to 4 hours for calculation, right? And how it can be achievable. Finally, if we are talking about full calculation, it takes for calculation full portfolio. But if you are talking about trading activity, you should calculate a single transaction, but only with information about market snapshot and transaction version. So finally, all the system runs for up to the half second with all this communication between different services. Yes, I believe it's everything that I'd like to say for today. And I hope for your questions. And it's now it's part to discuss everything. Yeah.
Thank you very much. Thank you, Andrei. It was a good run. Please raise your hands to ask questions. I will give you 30 seconds. 29, 28. Yes, please. Please stand up so we could have a better
Hello,
look.
thank you for the great presentation. My question is, why did you choose Mongo, and did you consider choosing other alternatives, maybe?
Yes, most of this I explained in Mongo database. There is no requirements for performance. There is no requirements for writing and reading, and there is no requirements to. But there is requirements that we calculate only once. We persist that information only once, and finally we not overwrite that information. So there is no requirements to keep like a strong consistency. So also second point, to implement additional fields or drop old fields. So for example, we can have the same risk calculation, the same trade type, the same risk type. But for example, yesterday it was one set of fields, but today another set of fields calculated. And we can proceed everything. It's kind of flexibility that we are actually happy finally after development. We used Oracle database in past. We used strong database in past. But we found it's very time-consuming for development and development cycle.
Okay, thank you.
Thank you. By the way, guys, if you're thirsty, there's water on the table. Feel free to stand up and pour yourself a glass. I have a question for you after we take this one.
Hello, thank you for presentation. I would like to ask how Kubernetes goes well or not when you're talking about high-frequency trading and very quick risk calculation, because this is where it goes wrong, especially with CNI network, especially with delays added by hypervisors, etc. So, main question:
Yeah.
Is it Kubernetes okay for high-frequency trading and FX companies or not? Thank you.
Yes, it's a main reason why I mentioned that some services in the cloud, but some services not in the cloud. So some services deployed on our internal instance. It's like old-style solution. We have hardware. It's main reason, because if you're talking about low latency performance, we expect our service 24/5, because it depends on no weekends. And we actually expect like a 99.99999 that service actually in running state, right? If you're talking about automated trading, if not high frequency, automated trading, for example, to cover some position or to hedge risk, it's mostly flows with old-style instances, old-style hardware. So I totally understand your question, and it's one of the main issues why all the systems finally will not be like in cloud style. All time, it's some trade-off between flexibility, development, and all style, but finally we should serve our business, right? And sometimes it's much cheaper just to get out of this development, get out of this long cycle, and yes, and make job finally. So answering on your question, we not calculate in cloud all actual performance calculations, yeah.
Okay, good. Let me take you to the beginning of your presentation, and finally, what's the purpose to calculate risk, and how do you make? Is it to make profit, or there are other ideas?
Yeah. So as I discussed, so let's for example, there is example like Apple phone production, and this phone sold in different countries. For example, in China, in Cyprus, in United Kingdom, in Germany, in America, but company finally head office in America, located in America, and they apply tax in America. And some way they should know how much money finally from different branches, from different places in the world, they should sign in tax. But it's a risk, because, for example, if you say, I pay 10,000, maybe 11, maybe 9, no one knows, but it doesn't work that way. Because if they pay less tax than they just sign, it's going to be like terrible, because they're going to be fined, they're going to be, it's not their business, right? So it's the main reason, for example, Apple approached to some huge bank, for example, JP Morgan, and asked, I wouldn't like to think about money. I wouldn't like to think about future. I'd like to know exactly. So fix that rate for that date in future for me. And JP Morgan like, yeah, sure, but you should pay for that. And everyone is happy, because they just get out of business that they not understand. They're not prepared for that field. So they pay to fight big banks for this field, yeah.
Andrei, could you please turn on the final slide with the QR code?
Oh, yeah.
I need to remind you, before we take the final question, I need to remind you about rating the speakers. Please take take the whole survey thing seriously, because we really need your opinions, we really need your thoughts. And so, after the final question, we'll take the speaker outside to the discussion zone, where you can ask more questions in Russian, Armenian, or Greek, any language you speak, please. And now the final question, please.
I have final 2 questions.
Whatever.
Could you please go to the previous slide? So with this end-to-end latency to the UI, does your system update the UI while it's inactive? Because with this latency, you could just avoid that, minimize the load on the system, or...
Oh, sorry, could you...
I mean, do you update the UI when the UI is inactive for some reason, like other tab or other window is on top of the user's UI?
So, do you mean what do you mean mentioning update of UI?
No, like changing events, risk state. This state.
So, let me describe an example. For example, your trader opens one portfolio. So there is a tab with numbers, calculations, risk, right? For some timeline opening, that portfolio, it's a single point of time. So that risk for that time. But there is change, right? And no one expects that these numbers switch and like move all time. So we inform our users, so like there is new risk calculated, but would you like to switch to the new time point or not? And it's very important because, for example, new risk calculated, it means new state, but maybe sales or business, some guy has not finished with the previous state because, and he's not ready to update. So, for example, if you are a sale or trader, you are not checking that risk all time. You're checking now, you're checking with another applications, and you're back after, for example, 10 minutes. So there is a work cycle, right? So it's no one just use this one single application for management everything. It's like check information, check information, check information, check information, and back to that one. And sometimes it may be check information, check information, check information, check information, check information. For example, 2 applications might be used. And for example, if one application moves to the next timeline and the old application in the old timeline, people just not understand. They can't match numbers. Because, for example, difference may be very little, for example, 10%, right? Or 5% or 1%. And finally, there is difference, like in one window there is 1,000, but in another 1,001. And for example, in old window like 1002, there is no clear understanding. So it's very important to inform user that we actually have a new calculated risk. But actually, would you like to see it or not?
Perfect, thanks. Just a simple last question linked. Where do you store the end user state? Is it on front end or on back end?
It depends on application. For some application, we yes. So it's very interesting question, and recently we discussed with.
Without the microphone on your head.
Yes.
Yes.
All right.
Without microphone. Yes.
Okay.
So, but generally say for some applications state in UI, and for some applications state in backend. Yeah.
Thank you.
Thank you, guys. Andrei, thank you for your talk. We will ask you to. Yes. You need to feel the applause. Yes. So now you go to the discussion zone right outside the hall, and we have approximately 20 minutes to breathe, to talk, and to maybe ask final questions. We'll continue at 11:10 over here. Have a nice day, guys. Check out the program. Make sure you're in the right hall for the next talk.